So in question 5, I did a video where I showed you how to determine the sides of a triangle that's a 30, 60, 90. And in number 6, they want you to work with that sort of idea, and they want you to find a point that you get the coordinates for with, and starting with a 30-degree angle. Well, it's kind of arbitrary, because as long as they follow a certain pattern, you could have chosen any number of points. So I'll walk you through what I mean here. We've got 30 degrees here, and we stated in number 5 that if we had 1 here, then our other sides of the triangle would follow a pattern where this would be 1/2, and this would actually be √3/2. Now that's from number 5, and it's in the other video, so if you want to review how we did that, you can go back to those ones. Now, what they want here is, what are the coordinate points? So if our r is 1, then our points will be √3/2 and 1/2. So that could be an answer. But they're kind of expecting you to choose a different value for r. And what happens then is it's like you're just blowing that same triangle up by a certain value. So say, for example, you chose to make your r 3. So if this were 3 instead, then I would be multiplying this by 3 to get my new coordinate, which would be 3/2. And I would be multiplying this by 3 to get my new coordinate, which would be 3√3/2, for example. If I wanted to do something even bigger to get rid of that fraction, I could multiply it by something that would make the fraction go away. So it's over 2. Well, I wouldn't have to go bigger. I could just multiply it by 2. So I could try getting rid of all of this and just make this 1 into a 2. If that's a 2, then 1/2 times 2 equals 1. √3/2 times 2, I'm just blowing it up, times 2 equals √3. So my coordinate point in that case could be √3 and 1. Anything along that pattern, it could be 2√3 and 2, it could be 3√3 and 3, it could be, you're just multiplying it by whatever number you put here. So it's kind of, I would probably just do the 2 because it's nice and tidy, and then you've got that point √3 and 1 that follows the right pattern. It's just enlargement of the basic one where r was 1, and we came up with these points. Okay, so I'll just take this extra, well, whatever. I'll put these guys over here. So this would be √3 and 1 if r is 2. So then they want you to use 45 degrees to do the same thing. And so I'm just going to shorten this up so I can draw the 45 degrees. If I have a 45-degree triangle, we would look at that and recognize that if this is 45 degrees, then this also is 45 degrees, which means that y and x are equal, and therefore I can choose any value in the world for x and y as long as they're equal. So I could say if x equals y, then any point where x and y are the same will work. I can do 3 and 3, 4 and 4, 3.725 and 3.725. As long as they're the same, they're going to get me a triangle with 45 degree right here, because that one's going to be 45 as well, because that one's got to be 90. They all have to add to 1 at 180 and all that. The last one is 60 degrees that they give me to play with. And for 60 degrees, I'm just going to draw my triangle in here a little closer. It's the flip of this one, because this is 60 degrees right here. So it's going to look like that, 60 degrees. Da, 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 da. And it's going to follow the same pattern. If this was 1, then this would be root 3 over 2, and this would be 1/2. And so I just turned that triangle. So I can just use the same ones here, but x and y are flipped because I flipped the triangle. So I could say that if r is 2, then I'm going to go root 3 over 2 times 2, which would be root 3. And this one would be 1/2 times 2, which is just 1. So then my point is 1 and root 3. It just wants you to understand there's some relationships going on here. So if I have a 30-degree triangle, then my coordinate points for P are always going to follow the same pattern. It's always going to be multiples of these guys. And if I have a 60-degree triangle, then it's going to follow the same pattern, but in reverse. So it's going to be multiples of these guys. And if you have a 45-degree triangle and you remember this rule, then it's fantastic because you know that x and y are the same and you can do all kinds of math shortcuts with that information.